Hi guys, thanks for coming to learn more about the modular smart contracts on Arweave. And for those less familiar with Arweave, obviously it's like a Cosmos-focused conference, so let me give you a bit of a background about the Arweave storage network, which is a blockchain that is focused purely on data storage, and it gives you a really strong guarantee of the persistence of data. So once you put in information on Arweave, it's going to be stored permanently. Obviously, it's a really bold statement, but it's based on the assumption that the storage cost, the hardware storage cost, will drop by half every 2 years. So whenever you put data on the Arweave, then part of the funds will go to the endowment fund that will sponsor the storage for all of the node operators. But there are some, let's say, issues with a new model and the focus on the storage that in order to properly see it and validate the data availability, the block time is not as you may expect from other chains. It's a bit slower, and also indexing a humongous amount of data. It's not a trivial task, but fortunately there are new solutions coming up in the space. And in my view, it's really important to take, let's say, non-standard approach in the blockchain development when all of the L1s and L2s are focusing on the throughput, on scaling the number of transactions that can fit into block, often forgetting about the data volume. And that's kind of an elephant in the room, as most of the blockchains cannot deal with a full state and full storage support. And why are we building on Arweave and developing smart contracts there? So we started as an Oracle company with a twist that we do not put the data directly on the targets chains like the EVM chains like Ethereum, Avalanche, Celo. We keep all of the information directly on Arweave, which is much more affordable. And also we pass the information through meta transaction, which allows us to interact with almost every EVM compatible chain without making any amendments in the code. As I mentioned, we keep the data on the Arweave, but we needed an extra layer of business logic, mostly to manage data access. So data providers can adjust their manifest specifying what kind of an information is going to be submitted. That can also amend the aggregation logic. All of the metadata is being managed by the smart contracts on Arweave, so it's like fully transparent to the users. And it's very important to maintain the data integrity. So all of the usual Oracle solutions with dispute resolution, when you can claim that the data is inaccurate and get some kind of a refund, it's also implemented using the smart contracts. And obviously the most important part is how actually incentivize all of the data providers to feed high quality data. And that's been done with the help of tokens, which are also powered by the smart contracts on Arweave. And with oracles at the moment, we got more than 3.5 billion data points fully persisted on Arweave, and the infrastructure is being managed by the smart contracts. So when we realize we need something more than just purely a storage, we look into the original SmartWeave idea, which was brought up by the core Arweave team. And it's a very simple idea to separate the code, the interactions from the actual state. So you only persist the bare minimum, the smart contract code, and all of the inputs to transactions. But the state is something ephemeral that could be always recomputed from scratch. Therefore, you get amazing flexibility, but also the part that the state can always be evaluated is a tricky one. So it looks great on a paper, but when we started playing with that and work with many projects that were taking the original SmartWeave concept, we ran into a lot of issues. So the more popular use cases were actually taking a pretty long time to evaluate. So it's a very naive assumption that you can always recompute the full state, that every user will become a full node. And one of the projects that we started working with and trying to improve. So the contracts were taking 2 days for the full evaluation, which was obviously a no-go for the current state of the SmartWeave. And we started improving that step by step. So the main issue was obviously the fact that all of the contracts needed to fetch the data directly from Arweave, from this humongous storage chain. And obviously you got the usual issues of the data transfer and also extracting from multiple nodes. And that was taking a long time to evaluate. So we quickly implemented a few fixes. The first one was something we call warp cache, which is a cache around the node or a client evaluating contract transactions. And it obviously helps to limit a number of outgoing requests to the base Arweave layer. And we also built an indexing layer, we call it gateway, that listens to the changes to the Arweave storage, picks only the SmartWeave transactions, and then offer a proper indexing for faster queries. So this helped us a lot to cut down the evaluation costs. But there were other issues that we encountered. So it's really important for a mature smart contract environment to offer the cross-contract calls. And that was tricky in the original version of the SmartWeave, which relied on something called a foreign calls protocol. And whenever you wanted to communicate between two contracts, you need to create a third intermediary contract and then persist there all of the requests to write or read data. And that's an interesting design, but it got a few flaws from the point of view of transactionality, but also from the point of view of efficiency of the state evaluation. So we decided to get rid of this pattern and replace it with our own methodology. We call it like predict and verify method. So whenever we see in a contract a possibility that another contract will be invoked, and we do it by making a run with a smart contract, it's something very similar to a gas estimate in Ethereum. Then we create a path of execution and we persist that path of execution in the transactions. And whenever that path of execution is being actually evaluated by a client, we check if the assumptions were accurate, because obviously something may happen in the middle. And if it's fine, then we allow to evaluate the contract. And that's much more efficient. Obviously, you get a possibility to have like a synchronous multi-contract call, like contract I, calling contract B, and from contract B, contract C, and even back to contract I. That's perfectly fine. Also, the basic SmartWeave contracts were mostly written in Java or TypeScript, and obviously that's not the most secure environment to execute, let's say, production-ready contracts, as you are risking any possibility of hijacking the environment of the client executor. That's why we decided to sandbox the execution into WebAssembly. And apart from the security, we obviously got a really significant speed improvement, and we get the ability to execute contracts written in multiple languages out of the box. So we got a full support for assembly script and Rust. Rust is like the most popular language at the moment, and we also support Go for that. And that's the next step in our evolution, because having a WASM abstracted runtime environment allows us to introduce metering and to manage the transactions in a more meaningful way, so we can calculate what were the cost of execution and then offer evaluation of smart contract as a service. Another issue with Arweave that I mentioned at the beginning was the fact that the time of mining a block, it could be quite long and significant, because sometimes when there is a lot of data, there is a need to have a lot of checks before it could be included in the block. That's connected with the block with consensus model. When you need to present a proof of data probing before being able to write a block into the network. So sometimes this process can take up to a few minutes, and that's definitely not reasonable for end users to interact with the smart contracts. So we integrated with another project in the Arweave ecosystem called Bundler. And Bundler is a really useful service that allows you to get a commitment, a guarantee of data seeding immediately, and then Bundler and their nodes are responsible to deliver the data to the network, taking care of all of the possible network forks and delays resubmitting the data. So we rely on the Bundler guarantees, and that allows us to index the incoming transaction much faster. Obviously, as I mentioned, that the possibilities of fork and the delay, we cannot rely on the final placement of transactions in the block. We needed to add a service that intercepts the transactions sent by users before they go to Bundler and introduce a sequence, a deterministic predictable sequence. It's very similar to what happens in the rollup networks. So we need to order the transactions for a proper evaluation, and that's why we introduced this service. Obviously, currently it's centralized, but at least we get a few ideas to make it like blind, so we cannot censorship the transactions incoming. We just verify the hash, and then later on, when the order ID is attached, we can pass that transaction further. And as I mentioned, SmartWeave was relying on the assumption that everyone and every user can become a full node. That's very important to have the possibility of everyone to check the full history of transaction, but that's also not very efficient if you are addressing the mass adoption. So we decided to create something we call distributed execution network, when we get the technology to spin off a few nodes that will listen to the subset of transactions that happen between the contract that we are interested. You may think about it as a application-specific subnet that will evaluate only this part of the transactions and give you an access to the evaluated state much faster in the real time. And at the moment, we use a random probing, like a few sessions of querying the nodes and aggregating the data, so like super lightweight. But at the moment, it's not incentivized. So we offer that as a solution to all of the projects that are building on the Arweave network to faster evaluate the state and offer that to the users. But what we are really thinking about is building an incentivization layer that I will talk later on. So to summarize everything that I've been trying to explain, we can take a look at the typical transaction lifecycle in our Warp ecosystem. So whenever a user sends a transaction, it goes to sequencer to receive an order. So we can know how it relates to other transactions received by the network, then being seeded by Bundler, and Bundler managed to also the seeding to the basic Arweave storage network. Both commitments are being picked by our gateway, so we can serve the transaction directly from the Bundler, this, let's say, layer 2 storage improvement, but also directly from the Arweave network if someone will decide to go or surpass the Bundler service. And all of the transactions could be evaluated using our client, our SDK, with the full caching support, or delegated to the decentralized execution network to save on the resources and get a faster answer. And as I mentioned, we currently imagine all of this dance, the execution network, as kind of an application-specific subnets, but obviously it will be great to allow the inter-subnet communication, and also to introduce an incentive mechanism so we can properly guarantee that the state delivered by then is correct. So for that, we are exploring the Cosmos ecosystem as a place to have our base layer for the rollup mechanism. So any then can submit a state commitment to that network. in an optimistic way with a validation window. And if no one will challenge that, or if the challenge is properly solved using the bisection algorithm, so the whole network will only need to validate the single differing transactions, then other subnets can import a state from that subnet and use it in their own processing. So the most valid use case for that is that you can create a really fast and affordable in terms of the processing cost subnet, for example, for gaming or for an apps that is issuing, let's say, thousands of NFTs. But whenever you would like to monetize the outcome of that network, like you get a superhero and you try to sell it to some tokens with a significant value, then you can go through this settlement layer, wait a bit for the confirmation. So the state update is being verified and checked by the whole network, and then you can consume the results and receive financially valued tokens. And also it's really crucial at the early stage of the ecosystem to offer developers some tools, because what I talked was a bit abstract, but when someone comes to our environment and would like to try all of the solutions, it's important to offer some libraries, templates, tutorials. Also, we get a publicly available block explorer where you can see and check all of the validity of all of the transactions, the inputs, and also the currently evaluated state, together with a testnet when you can play on free and do your experiments with the network. And I think it's often overlooked, but having a high quality developers tools really helps for the early adoptions. And talking about adoptions, currently we started to build this product for ourselves to manage the Oracle's data integrity, but right now we got about 20 projects on Arweave actively using our framework, and there are more and more interesting use cases. I think here we got, for example, Accord that is doing a really cool stuff with the encrypted data storage. We also got another French team, Pianity, that is doing NFTs, and we got a bunch of others. Super interesting projects around NFTs, social media, token exchanges on Arweave utilizing the smart contracts infrastructure. So I encourage you to explore Warp, and if you're looking for a solution that can handle a lot of data, which is not possible in other chains, like data storage, like super interesting NFTs, or you are building your gaming infrastructure project that needs to deal with a lot of information, metadata about what's happening in the game, that could be a really interesting alternative to give it a try. And yeah, we got some developer resources, and we're always happy to talk and also to get the feedback about the infrastructure. We started to work on that a year ago. It's a very small team, and we are very pragmatic on making the solutions really useful to other developers. So thank you, guys.
Do we have questions for Jakub? I had one. What's been the most challenging part of building this product so far?
Sure. So on the implementation side, the actual technical side, like implementing the cross-contract calls from the WASP environment and synchronizing that also with the Arweave, that's pretty heavy engineering. So all of these, like say, modular blockchain structures, they look really great on the paper when you can produce the design, but when you get into the implementation, that's really tricky to synchronize a lot of stuff that's happening around and to maintain the performance while also being able to fully verify all of the transactions.
Thanks. All right. Thanks a lot, Jakub.
Thank you, guys.
Cheers.